Today's video will be about electrostatic potential energy. Now I'm sure most of you have heard of the first law of thermodynamics before. It states that energy cannot be created nor destroyed. It can only be converted between forms. But since it's pretty hard to track tiny particles when they're moving, let's only consider their potential energy for a moment. Let's say I had a proton and an electron, and they were separated by a distance we'll call r. If we remember that potential energy is just a measure of how much something wants to do something, we can get an idea of the potential energies of these particles by imagining what they would do in different scenarios. Let's say our two particles are just a few millimeters apart. Recall that protons and electrons are oppositely charged and that opposites attract. Because of this, the two particles are going to feel strongly attracted to each other. Now let's take those two same particles and make them infinitely far apart. Do you think they're going to feel anything from that distance? Probably not, right? Well, we could also say the same if they were both protons or electrons. No matter the charge, if the distance between two particles is very large, they won't feel anything towards each other. Now let's take those two particles with the same charge and push them close together. Recall from physics class that like repels like. Because of this, we can say that if two particles have the same charge, the closer they are to each other, the more they are going to want to push away from each other. We can express all of this with an equation that is commonly known as Coulomb's law. It states that the electrostatic potential energy of two particles is equal to K times Q over R, where Q is the charge of one particle, Q is the charge of the other particle, R is the distance between them, and K is a proportionality constant. If we graph this equation, we'll see that we get something that looks like this, where the line above the x-axis refers to whenever the charges are the same sign, while the line below the x-axis is associated with two particles containing opposite charges. As you can see, as the distance gets larger, the potential energy reaches zero, no matter the sign. When the charges are the same, decreasing the distance is going to result in an increase in potential energy, since we know that those particles don't really want to be near each other. But if we have two opposite signs, decreasing their distance also decreases their potential energy, since we're pushing two things that want to be together. This results in them being in what we call a lower energy state, which is something that is very favorable and will show up a lot in this course. But that's enough from me. Let's say I had four pairs of particles, each in a separate region of space. Using Coulomb's law, rank the pairs in order of lowest to highest electrostatic potential energy. Feel free to pause the video and give it a shot. So we know E equals K times Q over R. So let's write out the equation for each pair. If we simplify everything, we should get negative 1K over R, 3K over R, 3K over 2R, and negative 2K over 2R, which just simplifies to negative K over R. If we look carefully, we'll see that all four of these equations include a number being multiplied by K and divided by R. So let's just factor out those to compare the coefficients. Now we can rank everything numerically. Notice that pairs 1 and 4 are equal, and they're the only ones with negative potential energies, so they should go at the bottom of our list. We know 3 is greater than 3 halves, and 3 halves is greater than -1, so our final ranking should look like this. If we translate that into their answer choices, we will arrive with 1 equals 4 is less than 3 is less than 2. So now you know how to use Coulomb's law to compare electrostatic potential energies in different systems. You don't have to memorize how to draw the graph, but be sure to know what happens when we change the distance between two particles that have either the same or opposite charges. Feel free to leave a like or comment if you found this video helpful, and I hope to see you all next time.